Hello, everyone, and welcome to our weekly live stream at the Platformers. And today we are going to talk about an amazing topic, and we are going to do an intro to Remocal development with Miordi. And for that, we got Miordi expert with us. Eyal, how are you today?
I'm great. How are you, Guy?
I'm great. Would you like to introduce yourself?
Absolutely. So, my name is Eyal Bookchin. I'm the co-founder and CTO of a company called Metal Bear, where we build backend open source development tools for backend engineers. But really, in reality, we have just one, flagship project, and that's Mirror. So we'll dive into that a bit later.
Sounds awesome. And for everyone that don't know, like Miordi is an open source project. So while we are discussing that, you can take a look and first of all learn from Eyal what is Miordi and how you can benefit from it. And on the other side, go to the repo and give it a try. Um, One thing before we are starting is that we really would like everyone to participate. And if you have any questions, feel free to post them on the comments. If it's on YouTube, you can just comment on the video. And if it's on LinkedIn, just comment on the video on LinkedIn. And we will see the question and we will be able to answer them. Not me, but maybe Eyal, but feel free to ask the questions on the comments. So yeah, maybe you can walk us through a little bit about what is Remocal development.
Absolutely. So I have some slides ready. Maybe we could pull those up and let's go through the narrative. Yeah, first of all, as I said, I'm Eyal, CTO, co-founder along with Aviram Hassan at Metal Bear. We are a 2.5-year-old startup. We are completely remote, which is fun. Our team is spread globally, and we build open source tools, mostly in Rust, for any Rust fans in the audience. Let's talk about Mirror and the problem that it tries to solve, right? And this is a problem that really any, I think, cloud startup faces at some point. Um, and I think the best way to illustrate it is through the maturity process of a startup, right? So at the early stage, when you're small, you don't have a lot of users, you don't have a lot of microservices, you have a small database, and everything can be run locally. So it makes it really easy to test, right? Because your iterations are all done locally, and you don't really risk a lot by deploying a faulty product either, because you don't have a lot of users. Um, but then, of course, once you grow and you have a lot more users and a lot more microservices, and I gotta say, this is an old slide where we put 30%, 10 microservices. From our experience, it's a lot more. Like the proliferation of microservices in recent startups are just um, so it's a lot. It's a big architecture. It's unwieldy. It's difficult to run it locally. Your database is becoming bigger, and you can't really run everything locally. And so, the process gets a lot more awkward and difficult and risky. Um, and this is sort of the legacy loop that most of us know, and a lot of companies rely on. Uh, you know, um, with certain variations, but these are sort of the common building blocks where you start locally and you go as far as you can, and you use mocks or isolated tests or simulations. But eventually, you have to open a PR and go through CI and a code review. And then after that, you usually deploy to a staging environment, which we define as the most production-like environment the organization has that isn't actually production. Um, and to make it that way, you have to invest a lot of work. You have to invest a lot of effort. You have to make sure all the components are there on their latest stable version. You have to have populated databases. If you're using third-party APIs, for monitoring or maybe a third-party database, hosted database, etc., you'd want to have that as part of your deployment as well for your testing to be as effective as possible. Which is why this environment is usually manually set up and shared among the developers, which of course makes it a huge bottleneck and the worst step in the development process. Right. So just to sort of reiterate, you start locally, you have to do all this effort to simulate cloud conditions, and so like as a developer, you want to delay um, staging as much as you can. So you go as far as you can locally, and then you have to go through a PR, a CI, etc. That takes a while. And then, with staging, someone might be using it already. You don't want to clash. Or, there's the obverse of this, which if you deploy your untested code, you risk breaking it for everyone else. And of course, if you fail in any of these stages, it's all the way back to the first step. So,
Absolutely.
yeah.
And something that reminds me is that this is kind of the same flow of every code going into production, more or less that flow. And I remember that when we work in a smaller company, we had this process and we have like a dev or staging environment, and we share that. And when the company grows, it's like you need everyone to use the same environment, and then you need to schedule it, and then you need to understand who pushed last time some code in it. Is there any differentiation from the stable version to that one? And it become a little bit messy. Even if you're like 2 or 3 people, it can become a little bit messy.
hmm Exactly. And the thing is, it gets worse as the organization grows, both because the product grows, so it becomes more complex, more fragile, and because there are a lot more people competing for this environment. So, so the problem does not go anywhere on its own. But of course, this is not a new problem. We are not the first people to try to address it. And there are some common approaches that try to outdo this, sort of legacy loop. One is trying to run everything locally anyway, and there are some tools that, of course, make this easier, like Docker Compose, like Tilt, Scaffold. And of course, this is simple. You're still local. You're completely isolated. You have complete control, and you can run everything locally. But the bad here is that it's just impossible at some point. You hit a complexity ceiling, you hit a resource ceiling. So this is nice for early stage or startups with maybe smaller deployments, but it's not really practical for most of the industry. Of course, as a test environment, it's not as good as staging for the reasons we discussed before. You're not going to have third-party APIs. You're not going to have a populated database. And you're probably, as a developer, going to be responsible for maintaining it yourself. So, so there's this maintenance cost. And then a more sort of modern solution is personal cloud environments. And there are a lot of startups that provide this sort of solution as well. So you have sort of a replica of production for each developer in your organization. And great, so you don't have that resource ceiling anymore, and you're still isolated. So you can do whatever you want with the environment without the risk of clashing with other developers. But now you miss out on the convenience of local development. It's still not a great test environment. You're probably not going to have a fully populated database. And again, these third-party APIs are difficult to actually deploy with each personal environment and tear it down, of course. You're still going to have personal maintenance cost. And maybe most importantly, it doesn't really scale because it's you have an environment for every developer in your organization, and cloud is expensive. So, but yeah, go ahead.
And you can sometimes you can find yourself like write a system just to take care of those cloud environments, right?
Yeah, of course, because it's in the end like a really there are a lot of moving parts in the solution. So there's of course a maintenance cost, both personal for the developer and centralized for the DevOps team or the DevX team or whoever's in charge of actually deploying the system to the organization. And Remocal, the reason for our meeting here. So Remocal development sort of mixes the two, right? So the idea is that in microservice development, you're usually going to want to change just one or two microservices when you're developing at any given time. So you don't really need or care about changing everything else. And so the idea is that you run your microservice locally, but you connect it to a full cloud environment. So the microservice runs locally, everything else runs remotely. And the most common tool in this space, in this category, is Telepresence by Ambassador Labs. And of course, MirrorD is a Remocal development tool. And yeah, so the advantage here is now you can test on staging, right? You can use a shared environment that's got a database, third-party APIs, etc., like the ideal testing environment. And it's just the one environment, so it doesn't the cost doesn't grow with every developer joining the organization. But of course, the issue here is that you lose the isolation. So we all use the same environment, and we can clash with each other. And it's harder to recover from corruption because now you're probably dependent on the DevOps team or the DevX team or whoever's in charge of maintaining that shared environment. So MirrorD, right? Like obviously, we took these and we tried to address them. So as I said, MirrorD is a Remocal tool, and it lets you run a local process in the context of your cloud environment with access to all of the cloud resources, databases, APIs, storage, basically everything. And the idea is that you take that dev loop from before with all of these steps, and you shorten it drastically. You basically you shift left on staging, right? You can now test on staging from day one quickly and non-invasively towards the environment. And when you actually deploy the staging after all of these iterations that you do remotely, then you're good to go, right? Because you've already tested on that environment, so the chance that you'll fail there is much lower. So I'm going to explain. Yeah.
Yeah. So
Yeah.
I have a question. Like, I got some piece on the laptop of each one of the developers and some piece on the cloud, and they're like interacting with each other to create those Remocal environment, right?
Yeah, so I think the simplest way to explain it is like imagine you have one developer in the organization, right? So you have the staging environment in the cloud, and he has that one microservice, and together they sort of compose that Remocal ecosystem. And the thing is, every developer in the organization is going to have that experience with MirrorD because MirrorD makes it transparent to other people that other people are using MirrorD on that same environment, right? So what we try to do with MirrorD is I said non-invasively. We try to make it so using MirrorD on an environment does not mutate it, does not affect it in any way. The stable services are still running, and so multiple developers can use it concurrently without affecting the environment or each other.
Got it. Got it. And we also got some question from the audience by Carlos Santana. Carlos is also a host in these live streams. And Carlos asked, like, does this work when using kind for app? I guess it means like kind like Kubernetes local for the app and remote cloud for database, like remote cloud database.
That's an interesting question, very timely, because we've just encountered that same use case, very similar. So it does work. I think after the demo, I'll touch on that again and explain exactly how it works for that scenario. So
Sounds good. Sounds good.
yep. Um, Great. So let's quickly explain how MirrorD works, because it's key to sort of understanding why it works, and also I think it's pretty cool. Most of the other tools in the space do some sort of networking, sort of, they basically VPN your machine to the cluster. We chose a more difficult approach, but it has its advantages. Um, so in this scenario, let's assume I'm developing the user service. I'm now coding user service version 1.1, and I have version 1.0, the stable version, running in the cloud on the staging environment. Now, MirrorD has two main components. One is called the MirrorD layer, and the other is the MirrorD agent. The MirrorD layer is injected into your local binary, your local process. You don't have to do anything. You don't have to make any code changes. It's dynamically injected, and the agent runs on the cloud. So when you execute MirrorD, you have to give it like your local process. You're going to say, I want to run user service 1.1 in the context of 1.0 in the cloud. And the first thing that happens is that we start the agent, the MirrorD agent on the cloud. And the agent is going to run on the same network namespace, on the same node as user service version 1.0, as the pod that's running it. And it's going to do that because it's going to let it, to give it access to all of the resources that the user service has access to. So, traffic, files, environment variables, etc. And we're going to see why that's important. So once we have the agent running, and this is where the interesting part starts, what MirrorD does, the layer, it overrides all of the input and output syscalls for the local binary, right? So the file reads and writes, the incoming and outgoing traffic, the DNS calls, the environment variables, all of this is intercepted by MirrorD, and it is proxied to the cloud. And so if we take, a simple example, let's take a file read. When your local process tries to read a file, it calls a libc function for reading a file. MirrorD intercepts that. The layer intercepts that. It sends that call to the agent. The agent reads the file from the remote pod's file system, and it returns the answer to the local process. And it does that for traffic as well, for environment variables, etc. Basically, all of the sensory information for your process, resulting in your process thinking it's running in the cloud, right? Because it's running locally, but all of its input and output is coming from the cloud. So, yeah. So now you have sort of you can call it a sandbox, but your process is running in cloud conditions, and you can test it in the cloud without it actually running there. Yeah, so that's how MirrorD runs, how it works.
Oh, that's awesome. So kind of it's isolated environment which kind of proxy every request that needs the actually remote and local and create this bridge between them, right?
Yeah, you can say that. Yeah, exactly. And the nice thing, or one of the nice things about this approach, is we have this really fine-grained control over what happens locally and what happens remotely, right? Because we control every syscall. And so, of course, we can tell the process to, I don't know, read or listen to traffic locally, but read files remotely. But more realistically, we can tell it, this and this file we still need to read from my local machine, but this file needs to read remotely. Or, for example, this host name I want to access locally, but everything else, bring it from the remote machine. So this makes it really versatile and applicable to, because everyone's Kubernetes deployment is different. Like it's true, everyone says that and they're right. So you just need this really fine-grained control to be able to apply to all of them.
How do you see that going into action, like with separation to teams? Is there like a platform or DevOps team creating those configuration? Because this is something that not every developer and organization knows how to configure, and then they spread them to everyone in the Git repository of that service? Or is it something the developers create on their own and they need to understand what is dependent on their local or dependent on their remote?
Mhm. Yeah, so mirror-d, and we'll see it soon, relies on a simple configuration file. It's a JSON that can be, committed to Git and shared. And the JSON in organization usually applies to one microservice, right? So once I've configured mirror-d to work on one microservice, then I can commit it, and it's going to work for all of my teammates who develop for that service as well. Yeah, so that's that. I will commit a small violation and mention that there's also a paid version on top of mirror-d which adds capabilities meant for organizations. So management, collaboration, security. But yeah, everything we're going to see here is in the open source. So.
Perfect, perfect. And I really encourage people after you see the demo, go to the repo, go to the website, and then explore what is the value and what you can get out of it.
Yeah, absolutely. And just to sort of wrap up the idea, right? So with mirror-d, this is what the dev loop looks like, right? So you code and test locally, but remotely on staging. And so you get high quality testing right from the get-go. And once you do reach staging, then your chance of actually failing there is much lower because you've already tested in the conditions that staging provides. So yeah, so that's what the developers looks like after. Yeah, so that's that, and I guess if there are no more questions, we can do a demo.
Yeah, that sounds great. Just one thing before we starting the demo, I want to tell the audience back at home or whatever you are, if you have any questions, please post them on the comments. And after the demo, we will have some time to ask you all of your questions. So feel free to do that. Uh, and that's it. Let's start.
Okay, so before we get to the actual demo, so I've set up a test cluster on Kubernetes. It's on GCP, and this is the architecture. So we have a microservice called the IP visit counter, which counts the number of times an IP has visited it. It's accessible from the internet, so you can access it as we do the demo if you must. And the IP visit counter saves the IP to Redis. It accesses another microservice called the IP info service to get some extra info about it. And it sends a message to Kafka about the IP and returns a response to the client. So that's the architecture we have. And let me share my screen.
Cool. Now your screen's sharing.
Oh, cool. Okay. So first of all, so I'm going to do the demo in Golang, IntelliJ Golang. I haven't mentioned this, but mirror-d comes as an extension for Golang or VS Code or as a CLI tool. So I'm going to do the demo on Golang. As you see, I have the code for the IP visit counter already loaded. Like in the presentation, let's assume I'm developing version 1.1. I have 1.0 running in the cloud, and the first thing is installing the mirror-d plugin. So let's do that. There it is.
So is it available on Marketplace? Is it also available in VS Code?
Yes, absolutely.
Amazing.
And on Brew, so for the CLI.
Cool, cool. So a lot of options for people to just use it.
Yep, definitely. So now I have mirror-d installed. As far as prerequisites go, so I have my kube config directed to the cluster I mentioned, so I can see all the pods here. And what mirror-d added, what the plugin added, is this button. which doesn't really do anything when I click it, and these settings, which we'll go into later. First of all, so when I run without MirrorD, when I run this process, it's going to try to load some environment variables. And it didn't really do it because it's meant to be run remotely, so it's just going to fail when trying to read a file from an empty path. But now let's turn MirrorD on. And now when I run the process, I get these options. I can look at deployments or pods. And let's go for the IP visit counter deployment. This is going to be my target. So MirrorD is going to bring the context of the IP visit counter deployment to my local process. And now let's dive in. So I have the load config function, which if I step into it, I can see it now does read environment variables from the remote pod. Now I've received the path for this remote file. Just to sort of demonstrate, if I try to read it on my machine, so it doesn't exist, right? But MirrorD, of course, is going to read it from the cloud. So there we go. It does a couple of other things as setup. It connects to Redis. It connects to Kafka. And we're just going to let it run now. So now the process is running with MirrorD loaded. Next, I'm going to send it a request. Let me make sure. Yeah, so we have a breakpoint on the handler for the request. I'm going to go to Chrome and access my domain. And I've hit a breakpoint, right? Because the request has reached my local process. You can notice that the response has already been sent. That's because MirrorD, by default, it mirrors incoming traffic. So it sends a copy of the incoming traffic to my local machine, but the response is actually sent by the remote process. Sorry. Yeah, so I've received the response. I can already, I can debug it. This is already can be valuable for debugging. But what if I want to test the whole flow, right? What if I want my process to be the one that sends the response to the client? So now let's dive into MirrorD's configuration a little bit. So I can go to settings here. It's going to create a new file. So the MirrorD JSON, and I'm going to change incoming to steal. And I'm going to run MirrorD again. Oh, wait, before I do that, just for the demonstration, I'm going to change the response that my local process sends, right? So I'm going to say hi platformers. Now I'm going to run it. Again, I'll choose the deployment. Let it run. I'll remove the breakpoint because it's no longer interesting. And yeah. High platformers, right? So now it's my local process that answers this this request.
Wow.
So that's how we can test a whole flow. I'm just going to show another little neat thing, which, okay, so what if I don't want to affect the remote environment? What if I don't want to steal all of the traffic that reaches the remote service, right? Because that's the whole point of MirrorD. So we support a feature called HTTP filtering, which can be configured like so. And I already have a curl request ready with the header, so I'm gonna do that.
So what do you do now? You're just making sure that any request with that header will go to your environment, and the other request will go to the services that are already running on the remote cluster.
Exactly. Yeah.
Got it.
Yeah. So, yeah, just to wrap up this portion, so I'm going to bring the breakpoint back in, run with this deployment, um, wait for it to run. Okay, so we're back here, but of course, if I send a curl request with the header, then it's going to hit the breakpoint. Yeah, so this is really just the tip of the iceberg. There are a lot more features. I'm going to stop sharing now. So yeah, a lot more capabilities that make MirrorD really valuable for Remocal development. Um, so yeah, that's the demo. That's MirrorD.
It looks absolutely great. Like I have to say that the combination uh, uh, between like taking the good with local development, making it fast, making it fast that I can change the code and immediately see like the changes and get feedback from the thing I've just developed. And on the other side, relying on remote resources. I don't need to make my computer explode because I need to run 100 services on my small machine. It's
Mhm.
absolutely great, and the fact that it has some multi-tenancies, let's call that capabilities, so I'm able to run with other like developers and other Remocal environment on the same cluster. It kind of make it also cost effective. I really like it. Um, let's see if we got any question from the audience. And no, okay, that's fine. If people got some questions, feel free to comment on the video. I will try to check it once every few days. Something that I will add in here is that if you want to explore more, you can go into MirrorD website. I just put it onto the comments so you can go in there and explore, go to the tool, learn more. Um, and check everything. Eyal, any last tip or something that you want to mention before we go?
Yeah, I guess just as a summary, just to say this is not a new idea, Remocal development. It's not even a new word. I wish we could take credit for it, but I think the telepresence guys came up with it. Um, but yeah, which arouses a lot of skepticism. But what's new here is the implementation, and it makes a lot of difference. So it takes this Remocal idea and makes it reality. So it's already been adopted at a lot of large organizations. It works surprisingly, really well. Surprisingly, not for me, but maybe for you guys. So yeah, check it out. And we're available on Discord for any questions. So
Yeah, absolutely. I think it's, by the way, I think it's amazing for everyone, like to see that it can work on scale, etc., etc. I think those are the things that are the main concern, not the fact that it will work once on a demo, but the fact that you can scale it, because those are the problems. The problems are in scale of dozen and more developers.
mhm.
Cool. Eyal, first of all, thank you very much for joining us and let us learn a little bit about Remocal development and MiorD as a tool and how it implements Remocal development. Thank you, everyone, for watching us and joining us on this first live stream for the queue. And if you have any other questions, feel free to post them on the comments, and we will try to answer them offline, if that's fine with you, Eyal. Um,
Absolutely.
Cool. So check MirrorD website. Thank you, Eyal, for joining, and see you everyone next week.
Thank
Bye
you.
bye.